Thanks everyone for joining. We'll get started with things. Just to give everybody a little bit of background. So, thanks for joining. My name is Josh Arsenio. I'm a Director of Advisory Sales here at Security Compass, and I'll be one of your hosts for today's webinar. I'm joined today by Paul. Paul, you want to do a quick intro of who you are?
Yep, thanks, Josh. My name is Paul Riviere. I'm a technical director at Security Compass on the advisory team, responsible primarily for research and development in the offensive security space.
Great. And before we get started, I just want to, a few quick housekeeping items. First, we're going to record today's webinar and make it available after the event. So you'll receive a link to an email with a link to the recording. We encourage everybody to ask questions. There is a Q&A portion here, as well as a chat that you can direct your comments at the larger group or just the panelists here. And then at the end of the conversation, we'll kind of open the floor. We'll stop the recording. We'll all stay late if anybody wants to, talk shop, talk about SSRF, talk about cloud security in general. Just hang out and talk on topic. So we host these virtual kind of conference talks, these webinars, dive into really a wide range of cybersecurity topics. We do them at least every month, sometimes more frequently. And if you've attended any of our past webinars, welcome back. I'm sure that you'll see some of the same familiar themes of how we run things. And we're really looking for, a community engagement feel here. So we really do encourage some participation. Just about Security Compass, if you're not aware of who we were founded back in 2004 as a boutique pen testing consultancy. Today, Security Compass Advisory has one of the largest teams of consultants in Canada. As well as an international presence. We have an office in the United States, San Francisco. We have, an office in India. We have a bunch of remote workers. So we really have a really wide presence, and we focus on, pen testing at an enterprise scale. So doing large scale programs, cloud security, all aspects of cloud security, and red team services. So doing either, full scope red team operations or looking at more purple team type stuff. We just did, our previous webinar was about the MITRE ATT&CK cloud matrix. Encourage you to go back and look at that. But that's about us. And for today's webinar, we're really going to focus on SSRF vulnerabilities. And I'm pleased to have Jason Plummer with us today. He's a senior consultant here on our team. Jason specializes in cloud security and emerging technologies in general. Has a tremendous wealth of experience. So really excited about Jason's talk. But I do want to do, and also during the talk, we'll do a few poll questions. So if you can answer them, that would help to get some context of where you sit, and we can help to kind of steer the conversation that it's most helpful for you. And of course, we'll share those poll results. And with that, just before we get started, let's do a quick poll. Can we put the first poll question up? So just get an understanding of your familiarity with SSRF vulnerabilities. If you can answer the poll, just based on where you currently sit. And again, if you're using the web client or dialing in, obviously you can't see these poll questions, but again, we'll share those results with you in the follow-up email. All right, so let's see the poll results. Okay, so it looks like we have a bit of a mix here. So how familiar are you with SSRF vulnerabilities? We have a small portion of people that are experienced with finding and resolving them. An equally small portion of people that are really unsure of how they work in general. But the majority of people on this webinar right now have some knowledge of what they are and how they work, but maybe don't fully appreciate the impact. So good to know. I think that once we complete today, you'll have a much better understanding. So with that, I'll pass things over to Jason.
Hey, thanks, Josh. So as Josh was saying, hopefully after the session, you're in a better position to not only understand what SSRF is, but also appreciate the impact, particularly in cloud environments. So with that said, let's get started. So this is what we are going to try to cover today. And we'll start out with an introduction to SSRF vulnerabilities, a bit about how they work, why they matter, essentially why you should care about them. Then we'll move into defining a process for searching for SSRF. And we'll try to have that process be repeatable and something that you can use within your organization. Finally, we'll take a look at the protections against SSRF, understanding how they work, why they are not foolproof, and as a result, why avoiding SSRF isn't exactly a straightforward prospect. So with that, let's get started with the most obvious question, that is, what is SSRF? So there are a number of ways that it can be explained, and it's typically a longer discussion or definition, but the one that I found to be most concise is from MITRE, and this is the description for their CWE category, or Common Weakness and Enumeration category, if you're familiar with it. Essentially, it breaks down SSRF vulnerabilities into a specific number of components, the first of which is the web server receiving a URL or some similar type of request from an upstream component. That component can be a user, it could be another service, it doesn't really matter what that component is. SSRF vulnerabilities occur when that request is received and the server, after failing to properly validate the request destination, goes ahead and makes that request anyways. And the result is that the server makes that request to something that may not be an expected destination. So if you take a look at the diagram here, you'll see that broken down into its various components. The green arrows show the flow that the application should take in normal operation. The red arrows show the flow during an SSRF attack. And while you're looking at the diagram, I'd sort of encourage you to think about an internal application that you have that does some type of integration, potentially with Slack or Jira. And maybe it also allows users to set profile pictures or import like XML configuration files from OneDrive. And so with that in mind, we go through the individual components. The first part is for an attacker providing a URL to the vulnerable application. And in our sort of example application, this can be a Slack or Jira integration endpoint, or it can also be something from OneDrive with your image or XML file. That would be a normal operation. In the case of an SSRF attack, that would be a malicious payload, and that would be intended to sort of alter the destination to which the server makes that request. The next sort of critical component is the application not properly validating that URL, making sure that it actually does go to your Slack integration or to your Jira integration, or potentially to OneDrive. Then, after failing to validate that URL, the server goes ahead and makes that request anyway, and you'll see that as a result of that, an attacker could potentially access your internal resources, things like your internal Confluence wikis, your internal Jira, or your MongoDB, whatever other resources you might have that are protected. And this is critical to understand because these resources would all be behind the firewall, but because the firewall does allow access to your vulnerable application, and then your vulnerable application can be exploited to access these internal resources. The end sum is the attacker has access to your internal resources. So just sort of with this in mind, I think we have another poll question. So how significant do you typically consider SSRF vulnerabilities? I know we do have some folks that are somewhat familiar with them, may not fully appreciate their potential impact. And so with that in mind, how would you typically rate the SSRF vulnerabilities when you come across them? And what sort of priority would you put on remediating them? So the three options we have are higher priority, same as with other vulnerabilities, medium priority or context dependent, and the third and final option would be lower priority due to reduced risk. Just looking at the results, we have sort of a mix, 45% treat it as higher priority, 45% treat it as medium priority or context dependent, and 12% lower priority. So one of the things to sort of consider with any clouds or any security program is that if everything is a higher priority, then nothing is high priority. Conversely, SSRF is something that was typically and traditionally accepted. Historically, they've been viewed as low risk findings, but that is something that must be reconsidered in light of workloads migrating to cloud service providers. And I'll be so bold as to make the statement that SSRF is extremely dangerous in cloud environments. There is a case to be made that is potentially one of the more significant vulnerabilities within cloud-hosted applications. The reason for that is to do with the cloud service providers having internal HTTP endpoints, particularly the metadata service endpoints, as they're typically referred to. These internal endpoints allow access to sensitive deployment information. So if your application is hosted in, for example, EC2 in AWS, there's an internal endpoint that the application can interact with, that would get it information on network IP addresses and potentially the OS image that is used to deploy the application. It also allows you to get temporary credentials, and those credentials can then be used to access other cloud services from the same provider. That is typically how interactions take place between a cloud-hosted application and something like S3, for example. The sort of protection mechanism typically implemented is that this endpoint is only accessible from hosts within that cloud service environment. The problem is that SSRF changes that entire dynamic. If you can get the server to make those requests for you, it means that you don't actually have to be within the cloud environment, and you can simply exploit an existing SSRF vulnerability and have those requests made on your behalf. And those requests will succeed. And as an external attacker, you'd be able to gather the sensitive deployment information as well as potentially gathering credentials that would allow you to access existing cloud services. This is all in addition to the typical SSRF exposures and things like protocol smuggling, internal resource and sensitive information leakage. So having your workload in a cloud service provider's environment introduces an entirely new dynamic for your applications insofar as SSRF is concerned. And now there are several real-world examples that show exactly how dangerous this can be in the cloud. Possibly the best known one is Capital One. So in 2019, Capital One was affected by a breach that affected approximately 106 million people. These folks had their personal financial information made public during the breach. And industry estimates peg the cost for that breach somewhere between 100 and 300 million US dollars. So the way this worked is that the leaked data was within an AWS environment. And while specific details are not available, experts have sort of speculated on how this attack would have worked based on the information that is known. So speculation is that it is a result of an SSRF vulnerability within an application that was hosted within the same environment, same AWS environment. That SSRF vulnerability was used to access cloud credentials. Those credentials were then used to access the data storage service where the records for the affected people were hosted. It was then used to retrieve that information, which was subsequently made public. Another example is GitLab in December of 2019. This one is probably less widely known, but it is confirmed vulnerability disclosed on HackerOne, and this was reported in the course of a bug bounty program. And this related to a project import feature for GitLab where the URL was not properly validated, and that URL was provided as user input. The result is that for this application, which, as it turns out, was hosted in DigitalOcean, the internal endpoint ended up being accessible. As a result, as part of this bug bounty disclosure, there is redacted information for all of the DigitalOcean internal hosting details. Another example is the US Department of Defense. In this case, there was a Jira installation that was self-hosted within an AWS environment. And that Jira installation was vulnerable to SSRF. And the result was that the internal AWS endpoints were accessible to external users. And that resulted in, again, the deployment information, sensitive information being disclosed to external users. So the examples sort of show how common, as well as how dangerous the SSRF vulnerabilities within cloud environments can be. The examples are all sort of fairly well-respected companies in terms of technology and their maturity. And they were all affected to the point where quite significant damage could have been done. And in the case of Capital One, was in fact done. And so with that appreciation for sort of what SSRF can do, the question then becomes, how do we find it before it gets exploited? And is there a process that we can implement to help find this? And is that process something that we can easily repeat and apply to various applications? The answer to that question, at least in my view, is yes. So this is sort of a breakdown of the typical approach that I take when searching for SSRF vulnerabilities. The first phase is identification, and that relates to sort of identifying potential vectors and components that might be vulnerable, that are likely to be vulnerable. And that's just based on understanding how SSRF vulnerabilities occur, what are the components required for SSRF, as well as successfully exploiting it. And the next stage is with those components that you've identified as potentially vulnerable, we do an analysis of the application, take a look at how the application behaves, try to note any sort of unique or interesting behavior. And we feed that information into the third step, which is actually exploiting or attempting to exploit the vulnerabilities. That's where you try to determine not just if it's potentially likely, but if it is in fact vulnerable. So let's go through it a bit more detailed, step by step. Step one is identifying the potentially vulnerable components. And these relate to sort of two primary areas. The first is querying external services. And for that type of functionality or that type of feature set, what you're looking for is any part of the application that retrieves remote resources. In this regard, think of our example application, think of retrieving the XML config file from OneDrive, or retrieving your profile image from something like OneDrive or Instagram or wherever it's hosted on the internet. Another common type of feature that is sort of within this category is webhooks. And these webhooks are typically used to allow integration with external services and applications. And so think of something like GitLab or GitHub. And when you commit to your repo, you want to also trigger a build to make sure your application still builds. And if your GitLab or GitHub server is not on the same physical sort of host as the build server, and then you need some way to communicate with that. That's typically how webhooks are implemented. And so that when you make a commit to your repo, that repo triggers a request to your build server initiating that build. And the other type of resource or component that SSRF is frequently found in is the complex resource processing. And so for things like XML, which is a particularly complex format, It's difficult to parse accurately and safely. You can have XML external entity vulnerabilities leading to SSRF, or XXE, as it's called. You also have PDF generation, which is usually done by rendering HTML and then sort of printing it to PDF. The process of rendering it to HTML can introduce SSRF vulnerabilities. And finally, video conversion by its very nature is sort of an incredibly complex format. And it does allow for external resources. Think of things like subtitles, alternate audio streams, and those things can all be defined within various video formats. And then it requires anything that is doing processing on those components or on those resources to make requests externally. One of the things to note is that this entire process is significantly easier if accurate documentation exists for applications. And by that, what I mean is if you have sort of an inventory of what each application does, what the components are, how each component interacts with each other component, and then it's easy to just take a look at that documentation and identify the potential vectors. And it's much more complex if you have an application that has minimal documentation, and then you end up sort of not properly going through it because you're only looking for things like parameters that accept URLs, which does give you a start, but it does not give you sort of a complete analysis of your applications. And so that's step one. Step two is analyzing the behavior of the application. And in this stage, you want to inspect how the application behaves for each potential vector identified. So you're looking at things like how the request is made. Does it have any limitations? For example, does the request have to be an image, or rather, does the request have to return an image, or is it expecting something like a GitHub repo or an XML file? Identify any of those limitations, which will make step three harder. But you want to go at this stage, understand how your application behaves, what it's doing. You also want to gather information on the application. You want to answer questions like what framework is made, or what framework makes the request, what language is used for the application, any sort of version information that you can get. This would help you moving forward to step three. And step three would be actually attempting to exploit the component that you've identified. So this is sort of a cycle that you start with initially making the malicious requests with your basic payloads, just trying to get a response. Two of the things you want to particularly start with are the internal HTTP endpoint, also known as the cloud metadata endpoint, and internal port scanning, just to see if there's anything else that's running on the host that might be interesting. Once you've sort of had those initial scenarios run, understood what the results look like, and if there are any protections, you want to attempt the basic protection bypass. If the payload requires an image file, how is that done? Is it just looking for something that ends in .jpg, or is it actually reviewing the content it receives to make sure it's an image file? Does it require the URL to start with a certain domain? Anything like that. So we just go through repeating the refinements until you either sort of run out of known bypass scenarios, or you have a successful bypass scenario leading to exploitation. But to do that properly, you have to sort of understand how applications protect against SSRF. But before we sort of explore the protections, let's sort of dive in and make sure we all understand the core reasons for SSRF vulnerabilities. So at its very core, SSRF vulnerabilities result from one of two scenarios. Either the application is making a completely unintended request, or the application makes an intended request, but that request is to an unexpected destination or URL. In the case of unintended requests, they're typically a consequence of other existing vulnerabilities, and generally addressing those other vulnerabilities will resolve your SSRF concerns. In the case of the application making intended requests to an unexpected URL, you then want to make sure you're properly validating that URL and in sort of a manner that would allow you to avoid unexpected destinations and being provided and accepted by your application. The challenge there is that properly validating a URL is deceptively simple. So everyone in technology has seen a URL, has understood what it looks like, and can recognize one if I show it to you. The challenge is that just the verifying a URL format can become incredibly complex. If you've ever had a look at the relevant RFCs, they define a whole host of scenarios and how the URLs should be treated in those scenarios. And the problem is that that parsing is not applied consistently across libraries and frameworks. So that if you simply, in the case of Python, there is sort of one library that's used almost everywhere. And that results in sort of URLs being treated a certain way. But if you throw in something that technically meets the specification, but is not something that you typically see, and just identifying that URL and making sure that it is, in fact, a valid URL is difficult. Assuming you manage to verify that the input you received is, in fact, in a valid URL format, you then have to validate the destination. And the question then becomes, how do you do that? Typically, you compare it against a list. That's sort of common practice. But there are a number of scenarios that make that incredibly difficult. Do you have that list be the ones that are allowed? And do you have that list be the ones that are denied? After comparing it to that list, what happens when your URL is resolved to an IP address, assuming it was a domain to start with? And do you run the process again? What does that look like? And finally, what about HTTP redirects? What happens if after you initially validate everything is acceptable to your application, and the response you receive from this external resource is a redirect to something that you should not allow? Do you repeat the entire process all over again every time you encounter a redirect? How does that scale? You then sort of open yourself to one request being repeated and redirected multiple times. And then you have sort of a challenge in scaling those protections across your entire organization. So that said, these are the typical implementations when we talk about comparing the input against the list. We're typically talking about a blacklist or a whitelist. And those are the most common types of protections that are implemented for SSRF and input validation generally. In the case of blacklists, these define a list of destinations that the application does not allow. And it will allow everything that is not explicitly listed and defined within this list. This is incredibly flexible, and it's suitable in cases where the application sort of requires that flexibility. The reasons can be that you want to integrate with various components. You don't necessarily know what your users are going to implement. So coming back to your application, think of having the ability to change your profile picture from any image hosted on the internet. You don't necessarily want to restrict your users to something like Instagram or Google Drive or wherever. You want to have that flexibility open to your user. So the approach you take is, unless it's something that you know to be bad, you're going to allow it. And the problem is that that approach does have sort of a number of potential bypasses. As mentioned, the URL parsing inconsistencies can become a problem if a URL is parsed one way for validation, but then parsed a different way when the request is actually being sent. And you can have sort of a variation where something seems like it should be valid, but the request actually goes to a different destination. You then also have, as mentioned, the case of redirection. So if I submit a URL and it is sort of not in that list that is explicitly denied, the application could accept it, but if my response is just to redirect the application to a blacklisted destination, then that defeats the entire point of the blacklist. You also have the DNS records that can resolve to blacklisted destinations. By DNS records, I mean things like the A record with an IP address, or even in the case of IPv6, the quad A record. It can also be something as simple as a CNAME record leading you to a different domain entirely. Conversely, you have the whitelists, and this defines a list of trusted destinations, and anything that is not explicitly listed within these trusted destinations is going to be denied. This is sort of more locked down, less flexible, but it is suitable when the request destination can be predicted, or you're willing to have that destination restricted. So in the case of your application that allows you to modify your profile image, if you force the user to upload the image themselves, you can upload it to your own domain, or if you intend to support only something like Instagram, you can do that, or have that destination restricted in some way. This does have its own list of potential bypasses. Again, the URL parsing inconsistencies, if they're abused, can become a problem and a way to bypass these lists entirely. You also have to consider the rest of your application if you're implementing a whitelist, because even if you do define a small subset of your domains as being trusted destinations, if any one of those domains have an open redirect, those can be leveraged so that I can have malicious requests being sent, but it's being sort of redirected to from a trusted destination. Depending on which approach you take, as I said, the flexibility will be different for your applications. One of the things that is important to note is that regardless of which approach you take, it is going to be incredibly difficult to scale across your suite of applications. So for things like blacklists, you have to keep that current and updated every time there is sort of a new bypass technique that is defined. You have to go back and update all of your blacklists, make sure those are available, make sure those are defined, and make sure you're not allowing them. In the case of whitelists, it's a similar type of situation. As URL parsing inconsistencies become a problem and ways to abuse existing libraries and frameworks become well known, and those are likely to see sort of see activity across your applications. So it does become something that is incredibly difficult to scale. And regardless of which approach you take, it is not something that you can sort of set and forget. So with that in mind, if you could bring up the third poll question right now, just to get a feel of what things are like within your organization. So the question here is, how are you tackling a problem like validating URLs within your organization? The four responses: extremely complex due to the environment and security development maturity, strong controls and security development community. Third option, some technological controls in place and need refinement. Security development mechanisms in place, but need increased education. And then the final one is that you're unsure how to approach it within your environment. Okay, so just taking a look at the results, and it looks like the majority of folks have some technological controls in place, but appreciate that they do need refinement, and they do have secure development mechanisms in place, but need to increase education. That is sort of reflective of my experience across the board, and it is something that that is not entirely uncommon, the sort of gap between developers and security teams. But just to sort of summarize where we are with our methodology, our approach to finding and resolving SSRF within your organization. And there are sort of a few things that I sort of want you to take away from this lesson. The first is that SSRF vulnerabilities can be entry points. So I would want you to stop viewing them either as always high priority or always low priority, but view them in their context. If something that, if an application's trust can be abused in some way, go through to understand exactly how that abuse can be leveraged to gain further access into your organization, access sensitive resources. What's the worst that could happen with that access? And don't just immediately dismiss them. And again, if everything is a high priority, then nothing is sort of treated by your development teams as a high priority. And secondly, the ability to search, or the process we use for searching for SSRF is completely repeatable. And the process that I use, even if the specific techniques change, the process still remains the same. We still go through the three-step phase, even if the individual actions at each step will change. Again, crucial thing to remember here is that accurate documentation does make this process go much more smoothly. If you have documentation you can rely on, it just accelerates the entire process of identifying the potential components that you need to investigate. And then finally, as might be reflected in that poll, there is sort of a multi-pronged approach that you should be taking to preventing SSRF. And one of the things that I typically recommend is that you assume there will be a vulnerability and then plan accordingly. What do I mean by that? As I said, the way blacklists work, they're difficult to scale, things might change. So if bypass becomes well known before you're able to update it across your suite of applications, that will lead to an SSRF vulnerability. And your only hope is that you have compensating controls in place so that even if that SSRF vulnerability is properly exploited and fully exploited, the impact is significantly reduced because of your compensating controls. So then that leads to the question, now that we can find it, now that we understand why it's important to address and some of the sort of techniques that might be used, what would I recommend to protect against it? Like I said, you want to take a multi-pronged approach. So at your application level, you want to implement whitelists ideally, or blacklists if whitelists are not possible. When you're evaluating against these lists, you want to make sure that you're consistently handling your input. So URL parsing is consistent between validation and request. You want to disable following any redirect for any external resources that you intend to retrieve. And like I said, you want to implement a defense in depth approach. So beyond your application, you want to implement architectural changes. So isolating components that retrieve those remote resources is something that is recommended, particularly in the cloud where it's easy to sort of spin up an isolated server and just have that host interact with the external world, treat that as untrusted, and make sure that that host has only the privileges that it needs to function. In a similar vein, you also want to limit network access so that even if an SSRF vulnerability exists and is exploited, the impact is not felt, you're not able to have an attacker getting feedback from that application. That makes exploiting SSRF vulnerabilities incredibly difficult if you can't see what's going on. You have no idea if something worked or not. You also want to restrict access to anything that the application doesn't need. So in our earlier diagram, the application was able to access multiple internal services, most of which might not have been necessary for the functioning of the application. In those cases, you want to make sure that the application has what it needs to run, but nothing more. And one recommendation that is particularly important for cloud service provider environments, just because of how they work, the application roles associated with a vulnerable application, it should be restricted and permission granted only to the services that are required. So if your application is entirely self-contained, it can run on the host. There is no interaction with external services. There should be no profile associated with it. And if it interacts with the database, the credentials should only allow it to interact with that particular database. And not necessarily the database service, just the database that is used for the application. I think if you implement these controls, you can have sort of secure application insofar as the knowledge of SSRF vulnerabilities exists today. And one thing that is important is that that knowledge is consistently changing. So this is something that would need to be revisited on a periodic basis. And it's not necessarily something that you can, like I said, set it when the application is built and then never revisit it again. It's something that will need to be constantly reviewed and monitored and then addressed if anything is sort of identified during this process. With that said, that's what I have for you today. And so I thank you for taking the time out of your day to join us. As Josh said, there are going to be sort of a Q&A session, or there are going to be questions afterwards. So I think I can hand it back to Josh to sort of take us from there.
Thanks, Jason. That was great. Yeah, we do have some questions that have come in. So just reading through some, a lot of them are related to kind of detection or prevention, really, and how do we start to apply some of the controls you mentioned. So I can read through these. There's some in the Q&A, but for the people that are here on the call, you know, everybody's muted, but you can unmute and feel free to raise your hand or just kind of ask a question. You know, this is an open conversation. So let's see what we have here. So in particular to implementing a blacklist. So is there anything that should be implemented on a blacklist? Is there anything kind of particular, like get any more detailed on that?
Yeah, so it sort of would vary depending on your deployment, but in the case of cloud service providers, one of the things you want to make sure is always on your blacklist is the metadata service, the internal endpoint. And for the more common providers, AWS, Azure, GCE, and DigitalOcean as well, and that would be an IP address of 169.254.169.254. In addition to that cloud metadata service endpoint, you also want to blacklist anything on localhost. There's never a good reason to have an external user provide you with an address that resolves to your application. And if that is your design, there are better ways to address it. And the reason you want to include that on your blacklist is because that could lead to interactions between your vulnerable application and anything else that is hosted on your server. That is actually how other SSRF impacts that are not cloud specific are typically exploited. So things like protocol smuggling interact with different services on the box. That's why you always want to make sure that localhost is defined. And when I say localhost, I don't just mean the localhost keyword. I mean localhost, the loopback IP addresses for IPv4, the loopback IP addresses for IPv6 as well.
All right.
Yeah, great. Thank you on that.
No worries.
I have another question here. There's actually a couple here that are all somewhat related, and it's about finding these vulnerabilities once they're kind of in your environment, kind of in your wild. So probably from the perspective of a, information security team as opposed to the developer team. And it's like, what are some tools that you can use? What are some available techniques? Is there any kind of automated tools to do this at scale, either continuously or as part of an assessment? Like, is there any practical tools that people can use?
So in terms of sort of application level detection using automated tools, SAST and DAST tools do a certain extent will detect some of these. The problem is if even if you have validations in place, something like DNS redirection, that's not something that a DAST tool will necessarily know how to do. You could potentially have your fuzzing tools just go through it for potential URL parsing inconsistencies, and just to see if what you're validating is exactly what you are requesting. But in terms of detecting these at scale, it's something that's incredibly difficult to do. What you want to do is to make sure that when they exist, you can immediately identify that it does exist. So in particular with cloud service environments, you want to make sure that anything that uses your credentials, they are coming from the box you expect it to come from. So what I mean by that is, if your application is hosted within your cloud environment, and that application has access to the temporary roles and the temporary credentials to access other services, that should be the only place that those credentials are used. You should have detections within your cloud environment for any instance of those credentials being used not on that box. It doesn't necessarily help preventing it, but it could help immediately identifying something went wrong and addressing it before 106 odd million records are downloaded by an external attacker.
Well, thanks. I had some other questions here that came in, and I think it's more from cloud security people specifically. Like SSRF is not a new class of vulnerability, but once you have a cloud-hosted environment, and a lot of the impacts you talked about today were really kind of talking about cloud-hosted environments as opposed to web server in a data center. But from a cloud security team perspective, is using tools like Dome 9 or Prisma Cloud and kind of these continuous compliance, like, does that play a role in it? Because you talked a lot about isolation and kind of enforcing these privilege.
So if you have sort of adoption within your organization of a cloud service provider or multiple providers, one of the things you want to enforce is sort of a best practice architecture that does implement some of these things that we mentioned, making sure that the network access is restricted, making sure your architecture is what you expect it to be. And the easiest way to scale that across an entire organization is with continuous visibility tools like Dome 9 or Prisma. Those tools allow you to sort of quickly define what is expected of your applications, and then alert when it detects something that is not in keeping with your standards. Again, it doesn't necessarily prevent something from existing, but it does give you an early indication that something does exist, so you can hopefully address it before it becomes a significant problem.
Great, thank you. Just looking, there's one more question here. So it's calling back to a comment that you made that RF is facilitated or potentiated by other vulnerabilities. Are there other vulnerabilities that are typically associated with SSRF? I think that this is really coming from like a vulnerability management program where reevaluating some of the criticalities that would be applied to other findings. Is there anything you can say about the association of SSRF with other classes of vulnerability?
So one of the primary vectors or those other vulnerabilities are typically injection type vectors. So in the case of a PDF generation, if you have XXS or cross-site scripting rather, during that phase, instead of having your user make that request, you have sort of your server make that request. It then becomes the server side request forgery. If you have sort of injection where you can alter any content that a server is rendering or retrieving, anything where you can define a parameter and affect how the server behaves insofar as a request. From a vulnerability management perspective, those are typically already treated quite significantly. So it doesn't necessarily change how you want to triage those. It might just change what your short-term compensating controls are. So for example, if addressing one of those vulnerabilities requires an entirely new architecture for your application, that might not be something that is feasible within your 15-day, your 30-day window. You'd want to address sort of those concerns where you have compensating controls until your new application can be built. Or it's something to consider when you're requesting exemptions or sort of risk acceptance requests. Those are factors to consider when those types of vulnerabilities come up. But insofar as changing, making sure that this one is no longer just a low, as opposed to being in your 90-day window and trying to have it elevated, it's not necessarily something that would meaningfully change how that part is triaged.
Right, so really understand the context.
Yeah, it's more about putting each finding in context to make sure that when you do sort of go through your risk acceptance, you're meeting the right balance between what your developers can do and what in fact can happen.
Great, thanks. So it sounds like there's a lot of factors at play, from secure development to make sure that you're not introducing SSRF type vulnerabilities, to having strong security architecture to provide foundational baselines for people to build secure applications on that have some of these principles in place, to more continuous compliance type programs on the cloud security side, but as well as getting strength in your testing side to not only discover these vulnerabilities, but also to gain context as to the true impact and how it might be exploited. So SSRF consideration should play a role at several stages in the SDLC. So thank you very much, Jason, for kind of walking us through that. Thanks everybody for joining.